Good morning, students. The last class we discussed about periodical properties in that atomic radius, covalent radius, and van der Waals radius, and metallic radius. And we also discussed the variation of the atomic radius in groups and periods, and factors which controls the atomic radius, and why it is not possible to determine the exact atomic radius. We all discussed in previous video. Now we are going to talk about ionic radius. That ionic radius where we studied in ionic radius, while we talking that atomic radius of the different types is based on the either metal or non-metal. In that covalent radius, metallic radius, and van der Waals radius. Now we are going to talk about that ionic radius. You see the ionic radius. Ionic is nothing but ions, correct? No, ions. It having charged particles. It may be a positive ion or a negative ion, correct? No, the radius is nothing but size, means size of the charged particles. We talk that it is a charge particles. Radius is nothing but size, correct? No, then ionic radius is nothing but charged particles, or you can also call as ionic radius is nothing but size of ions. Okay, we know that if we take that atom, we have that one is protons, second neutrons, third electrons. Protons having a positive charge, neutrons having a neutral, it is 0, electrons having a negative charge. That is, we know that. You see the electrons means the electrons participating in chemical reactions. Okay, atom having a tendency to lose the electron or gain electrons. You see ionic radius, the electrons, we will write that electrons participate in a chemical reaction. The ionic radius, it may be two types. You see, we will divide it that two types. One is loss of electron, one is gain of electron. Loss, it having a positive charge. Please, you want to be perfect. Loss of electron, it having a positive charge. Gain of electron, having a negative charge. Okay, positive charge, it will tell that cations. Quite commonly negative charges, we talk that anion. You see, cation means positive charge, and it must be have metal. The metal, every time it loses the electrons. Similarly, the non-metals, every time it gains, are attracted towards the metal. Non-metals. Okay, generally non-metals will be generally gain electrons. For example, we take metal. The metal, first it is a neutral state. I am taking it is a atom, that is metal. It have neutral. If it loses the electron, it shows positive. Loses the electron, it shows positive. Similarly, you see X plus its neutral plus it gaining the electron, it shows negative. See, this is the example I am taking. X is any metal. Okay, here metal, it is non-metal I am taking. We take atom for example. Okay, the two types, alter losing and cation. We told that is a positive and negative, or cation or anion. Now we tell that cation radius, because it is ionic radius. No, then it is cation radius, anion radius. Okay, next we are going to define or definition for ionic radius. You see, the distance between the nucleus of two ions up to which the nucleus with having influencing it electrons. You see, I will write ionic radius is defined as the distance between nuclei of two ions up to which the nucleus has influence on its electron cloud. You see, this is a nucleus talking this electron. The electrons are influencing. Okay, do you understand? Means influencing. Okay, positive and negative. The important point of this ionic radius, first point, the radius of cation is smaller. First of all, then radius of cation is smaller means metal will be small. Then neutral. Neutral means it is positive, means less. Correct? No, neutral. I will take this is a neutral. It is a proton. Proton is nothing but a loss of electron. Correct? No, this is neutral. Electron, it is electrons are gaining. Correct? No, electrons are gaining. Then see, the neutral, the cation, we told this cation. No, this cation radius is smaller than neutral atom or parent atom. Okay, you understand this? The radius of cation smaller than parent atom, or we can tell that neutral atom. Then if cation is smaller, what happens about the anion? It is bigger than the pair. You see, it is bigger. No, it's neutral, having neutrally the electrons is added, then it will be increases. Okay, here it will be decreases, here increases size, atomic size. I am telling, because atomic radius we are discussing a covalent radius and metallic radius and van der Waals. Now we are going to talk about ionic radius. The anion radius is bigger than parent atom. Okay, now we will study about first point. Why a cation is smaller in the size than the neutral? Why? Okay, then we will go to second. I will write the first point again. A cation is smaller size than neutral atom. Why? Okay, for that I will explain. For example, you will take a lithium. lithium is alkyl metal, it loses the electron. It is neutral state. See, it is in neutral state. Neutral, correct? No. Now what happened? It loses electron. Then lithium plus. It loses one electron. For that I added plus. If you write the electron configuration for lithium, the atomic number is 3. Then we'll write 1s2, 2s1, correct? No. Similarly, for what we'll write here, you see the lithium plus lithium cation. Okay, what happened? 1s2. The 2s1 electron is loses. No, for that I am writing 1s2. If you write for diagram, it is 1s2, 2s1, correct? No. You come to lithium plus, it will only 1. You see what happening here? Here the electron is 3, proton is also 3. Here electron is 2, proton is 3. It decreases the electron when lithium to lithium plus. Okay, then nuclear charges will be increases. You see here atomic size will be smaller when compared to lithium. Lithium plus is smaller compared to lithium. Then nuclear charges increases. Okay, we'll write that nuclear charge. Nuclear charge is nothing but a distance between the nucleus to electrons increases. Electrons pulled here. What happens? Electrons pulled to nucleus. Because now we'll write that why the cation is smaller than the neutral atoms, because the valency shell is removed. Correct? No? Your valency shell is removed. First point. Valency shell is removed. Second point, what you will write? Increases the nuclear charges. I will write here only the second point. Okay, increases the nuclear charges. These are two reasons why the cation is smaller in the size than the neutral atom. Okay, next we will going to study about second point. That is what they told that the radius of anion is larger than neutral atom. Why? Because we will take an example. Chlorine is in neutral state. If we add the electron to chlorine, a gaining of electrons, then Cl minus. Okay, we will write the electronic configuration for chlorine: 1s2, 2s2, 2p6, 3s2, 3p5. If you write for chlorine minus anion, 1s2, 2s2, 2p6, 3s2, 3p, adding of electrons, then it becomes 6. You see here 5, here 6, the electrons is added. Okay, then what happened? The diagram, it's having the 3 orbitals: 1s2, second orbital, third orbital. Correct? No. Here similarly 1s2, 3. Correct? No. What happens here? Electrons will be 17, protons 17. When come to here, the electrons is added. No, therefore it become 18. Proton become 17. The nuclear charges will be less. Because why it less? Because the electrons is more in this orbital. Okay, if electrons are more, the electrons are repulsion. You see, already it has in 5. For example, you take 1 2 3 4 5. These electrons are there. If we adding another electron to this, what happening? The electrons, because both are negative charges, the like charges will repel. Correct? No, like charge repel. Okay, repulsion, or we'll take repel also. Okay, if increases the electron, what happens? The nuclear charges will be decreases. Correct? No, because first point, repulsion of electrons. Second, what will write? Decreases in nuclear charges, or nuclear charges will be decreases. Okay, next we are going to talk about isoelectronic ions. Okay, isoelectronic ions. You see, iso, if you tell, it is iso is nothing but same. Electronic is nothing but, you know that already, it is electrons. Same electrons. Okay, same electrons. We will tell that the same number of electrons, but proton number will be differ. Here you see, same number of electrons, but proton number differ or different. For example, you take nitrogen minus oxygen, fluorine, sodium, magnesium, aluminum. Okay, these are all anion charges, these are all cation charges. Okay, you see, if we talk that atomic numbers will represent as Z. We talk the nitrogen is 7, oxygen 8, fluorine 9, sodium 11, magnesium 12, aluminum 13. Correct? No, these are what we telling that. Now if we talk the electrons, how much of electrons are there? You see, I will represent that electron. Correct? No, 7 minus is nothing but we want to add. Correct? No, minus is nothing but we want to add. 7 plus 3, how much? It is 10 electrons. Similarly, 8 minus 2, we will take 8 plus 2, because minus means nothing but we want to add. It will become 10. Similarly, 9 plus 1, 10. Here 11 plus indicates minus, minus 1 becomes 10. Similarly, 12 minus 2, 10. 13 minus 3, 10. You see, in mathematics, if minus comes, you will subtract it. But in chemicals, when come to chemistry, you want to add it. Okay, it is opposite to mathematics. Do you understand this? We will write the next written that atomic number, electrons. Now we are going to write the protons. Protons is 7 here 8, 9, 11, 12, 13. You see here, in this case, the electrons are same number of electrons, but different number of protons. You see. Okay. Now we'll define that. In this case, electron number is same, correct? No, electron number is same, but proton number different or indifferent. Then what happens? Then in the case of electrons are same but protons are different, in this case nuclear charge increases and electrons, they are strongly held together, decreases in size. You see, the electrons are strongly bonded. You see, the electrons are bonded, correct? No, here bonded. Here it loses also. The electrons are same but protons will be changing. Okay, that time the nuclear charges will be increases. Nuclear charge is nothing but a nuclear distance between the nucleus and the valency electrons. Similarly, the electrons, they are strong held together. The electrons valency strongly held because electrons are added to the orbital. They are strongly bonded. That time the size of atomic size will be decreases. Then we are going to talk about variation of ionic radius. Okay, what happens in ionic radius? If we talk in periodical table, groups, I think I don't want to tell what is groups and what is period. Already I taught you. In groups, the ionic radius, groups means top to bottom in periodical table. Groups, the ionic radius in groups top to bottom will be increases. Then what about in periods? Decreases. Okay, see why ionic radius increases? Because there is an addition of extra electron shell. Because they are addition of extra. Already I told in extra, adding the extra electron shell. Okay, example you take in first group lithium, sodium, potassium, okay, so on. What happens? See, the lithium having the charges plus lithium, sodium plus potassium having plus, then potassium is greater than sodium, sodium is greater than lithium. Okay, then we're going to talk about period. The ionic radius will be decreases, ionic radius will be decreases, the nuclear charges increases because nuclear charges increases. Okay, for example, take a third period. In this we know that sodium, magnesium, aluminum, Na plus, Mg2 plus, Al3 plus. Sodium is greater than magnesium, magnesium is greater than aluminum. Okay, similarly the ions, if we write for iodine, you see this is the state, the cations are smaller than anions, correct? No, cations are smaller than anions. Very very important point, this is cations smaller than